more on irrational numbers, but the most common type of irrational number that we encounter is, of course, surds. So let's look at surds. A surd is simply anything that includes a radical symbol. Now, I don't know whether you realise it's called a radical symbol, but that symbol is a radical symbol. But on top of that, cannot be calculated exactly. So something like the square root of 4 is not a surd, because you can work that out. It's 2. And it doesn't have to be square root, by the way. Cube root, fourth root, fifth root, they're all surds. Okay, some rules that allow us to manipulate surds, which hopefully we're familiar with. This is the one that allows us to pull out that common factor that's a perfect square. So root A times root B is root AB. Division, I guess what that's saying is it's up to you how you want to approach it. You could do the division first, then find the square root, or you can find the square root of each individual part, then do the division. Squaring is the inverse operation to square rooting. So if you're doing both, they must cancel out, and it just leaves you what's under the surd. So root 50, these are the sorts of things when we first encountered surds we're looking for a perfect square, but we want the biggest perfect square if there is more than one that goes in, and of course that's 25. Again, no, I wouldn't write that down, but that's what we're thinking. 25, oh yeah, we know the square root of 25, so we got 5 root 2. We talked about this one, you'll remember earlier when we were looking at algebra. Something like the square root of x cubed can be simplified down because it can be rewritten as the square root of x squared times square root of x. Square root of x squared, they cancel, and we get x root x. Remember, the quicker way of doing those ones is think of the index form. Here's a fraction one. Now in this case we can work out the bottom, but we can't work out the top. So we'll leave it as root 5 on 2. Again, we can work out the bottom. The top also can be simplified. So we get 2 root 5 on 3. Surd arithmetic. This sounds very familiar. You might recall the very first bit of theory I put up. It didn't say surds though, it said like terms. Because basically, surds are algebra. They're unknowns. We don't know what the square root of 2 is. We don't know what the square root of 5 is, and so on. And so that was the basis of algebra. We used x as an unknown. So all these surd rules and things like that pretty much are all the algebra rules. It's just an unknown, another type of pronumeral. And the difference with these ones is they can be simplified. Maybe you can do a bit more. So something like this, we're just collecting like terms, but in this case we call them like surds. So 3 root 3 plus 8 root 2. We can still have binomial products. First outside, inside, last. And in this case, nothing collects together. Difference of 2 squares. This comes up a lot in surds, of course, with rationalising the denominator. It's the whole point of it. These are what we call conjugate surds, when the surds are essentially the same, but the sign in the middle is different. One's a plus, one's a minus. They're called conjugates. And we get 2 minus 1, which is 1. Be real careful with that, by the way. So easy to go root 2 times root 2 and you write down 4, because you see 2 times 2. Perfect square. So 4 minus twice the product, 4 root 2, plus root 2 squared is 2. 6 minus 4 root 2. So I'm saying all those algebra rules still apply. Voila! That's today. Told you it was going to be a quick one.